we go. Or indeterminate. Infinity to the 0th. So we're going to mess around with the limit as x tends towards infinity of e to the 2x plus 3, all raised to the power of 1 over x. So we get infinity plus 3 in there, huh? All raised to the 0th power, tending towards it. None of it actually equals. That is where it's going towards. Limits. Let's jump into it. Oh, we go down into it and we're looking, and there it is. There's that piece we said we'd do. Infinity to the 0th power, and we're going to play that same game again. So what do we have here? We got the limit as x tends towards infinity, and we have what? E to the 2x plus 3 raised to the power of 1 over x. So there is our function. So I'm going to actually write this in black. Oops, not green. Come on, work with me, black. There we go. Limit as x tends towards infinity. So our function is f of x. So we can say that this is actually equal to the limit as x tends towards infinity of e to the ln of what's in blue. This e to the 2x plus 3 raised to the power of 1 over x. And what this is going to equal is e to the our final freaking answer. Now, what ends up happening? I'm going to move up. If you don't mind. I'm just going to take this little thing and show that this is equal. We can bring this. It's e to the limit as x tends towards infinity of ln of our function here. All right, we can bring the limit inside the function. So that's why this goes to this. We find the answer up here. We find this answer, and that's equal to L. So we can show that those two things have an equivalency there. So let's go get it, huh? Let's go solve the natural log of it, and we'll plug it in for our e. So one more time, the limit as x tends towards infinity of e to the 2x plus 3, all raised to the power of 1 over x. So instead, we're going to go solve this. We're going to go solve the limit as x tends towards infinity of ln of our function that's given. And once we get our answer, we're going to be able to know that our answer is going to be, if we say that this is equal to our L, well, our answer to this is just going to be equal to e to the L. E to the L. Okay, so let's go solve this thing. All right, so the whole point, the reason we do this is so we can get this 1 over x to fall to the front. So we'll start writing in one color now. So this is equal to the limit as x tends towards infinity. That x falls to the front. X times ln of e to the 2x plus 3. All right, there it is. Now remember, there's no equal sign in between these two here, right? Oops. There's no equal sign in between those two. So now we're just going to start handling this one. There it is. So let me zoom out a bit. Same game. If we plug infinity, we're going to get, oh shit, this is infinity. Oh, it's 1 over x. My bad. I was wondering, like, how is this? The exponent had to fall. It's 1 over x. That makes more sense. Well, we have 1 over x times ln of e to the 2x plus 1. Well, just write it differently, huh? Isn't this equal to the limit as x tends towards infinity of ln of e to the 2x plus 3 all over x? Well, that's the same thing. Well, let's keep rolling. I think we can L'Hopital's at this point because we have an infinity over an infinity case. That's how I knew I made a mistake when I had infinity times infinity. I was like, something's horribly wrong there. So now we can do L'Hopital's. So we're like, let's do some L'Hopital's. We let the reader know. Limit as x tends towards infinity. We take a derivative at the top. That's going to be 1 over whatever's inside there times the derivative of the inside. The derivative of e to the 2x plus 3 is e to the 2x times 2. And then the derivative of the bottom is equal to 1. All right. Hold on one moment. See, I forget that you don't actually get the break in the action while I'm screaming and yelling at my dogs like a madman. All right, continuing on. So we lost that denominator. And we have the limit as x tends towards infinity, and we got that 2e to the 2x over e to the 2x plus 3. Shoot. I think that's infinity over infinity. But we have tactics to handle this game. I've shown this one in class before we left. This is Very, very similar. We have our issue. It's not an x to a power of. This is an e to the power of something. Why don't we play a quick game here? I mean, you can keep L'Hopitalin. Actually, shit. Let's just L'Hopital this thing again. We got infinity over an infinity. I was going to do another game, show you something algebraic, but I think this might be the simplest way. Let's just go. We're going to hit it with another L'Hopitals. This is easy. Limit as x tends towards infinity. Now the derivative of 2 e to the 2x is 2 times 2 e to the 2x, or 4 e to the 2x, all over 2 times e to the 2x. Well, shit, I think a lot of things are going to cancel out here. You know what I mean? I think the e to the 2x's might kind of go away. And this is going to leave you with 4 over 2. And 4 over 2 is equal to, oh yeah, that's equal to 2. That thing's just equal to 2. Well, shit, we got one that didn't equal 0, huh? Good news. We ran through this. So, oh, shoot, look at how excited I was. I was all happy with myself. I got the right answer. But that's not the freaking answer. That's not our answer. This thing is just equal to our L. This is our 2. Our answer needs to get popped into here. Oh, shit. Our answer is actually e squared. So whatever we find by hitting it with a log, that is merely the exponent of e. So anytime we hit ourselves with a log first, then evaluate our limit, we need to take that value, our limiting value, and plug that into the exponent of e so we can get our correct solution. Well, our next one, we're going to be playing around with our last installment of L'Hopitals. We're going to go get after this 1 to the infinity, and this is going to pop up a lot in Calc 2. You'll see it a lot in series and sequence, so having a firm knowledge of it now is going to go a long ways to understanding the other concepts there. I'll see you in the last one.